Hello, welcome to lesson 2.1. This lesson is the chapter is all about frequency distributions and graphs. And so in this very first lesson, we're going to learn how to organize our data. So you're going to learn what a categorical frequency distribution is and how to make one. You're going to learn what a grouped frequency distribution is and how to read one. So a frequency is the number of times a value of the data occurs. It's a count, essentially. A relative frequency is the ratio. It can be a fraction or proportion. Sometimes also you can think of it as a percentage of the number of times a value of the data occurs in a set of all outcomes to the total number of outcomes. So I'm just going to show you this sample here. So it says the data in the table below represents the amount in inches of annual rainfall in a sample of towns. So you can see that there were 6 towns that had an average rainfall between 2.95 inches and 4.97 inches. So the relative frequency is 6 out of the total number of 50 towns. You can see there were 50 here. The cumulative frequency is accumulating the frequency. So frequency to frequency. So I'm just starting with what I had, 6, and then I'm adding to the next one. So the cumulative frequency is adding from the beginning up to and through that category. So we started with 6 towns, and now there are 6 plus 7, or 13 towns that have rainfall from 2.95 all the way through 6.99. Now we're going to add the next category. So there's a total of 6 plus 7 plus 15, or 28 towns that have less than or equal to 9.01 inches of rainfall. We're accumulating, we're adding the previous one. So now we're adding 28, the previous one, to the next total of 8. So we have 36, and then 36 plus 9 is 45, and then 45 plus 5 is 50. And you should have the total, so those match, 50 and 50. And then our relative frequency, I calculated those for you. So it would be my individual frequency divided by the total of 50. And these should add up to be 1 or 100%, because they could be interpreted as percentages. So this 0.3 would actually be interpreted as 30% if you wanted to interpret them as percentages. And the cumulative relative frequency is similar to the cumulative frequency, where this is accumulating the frequency. This one is accumulating the relative frequency. So we're going to start with the very first frequency of 0.12, and we're going to add the next one of 0.14 to get 0.26. And then we'll add the next one of 0.3 to get 0.56, and then 0.72, and then we'll add the next one to get 0.9. And then you should have a matching of 100% at the end. So we just learned about frequency, relative frequency, cumulative frequency, and cumulative relative frequency. So let's answer some questions about our data. So in statistics, we not only do mathematical calculations, but we interpret them and use them to inform us. So it says, find the percentage of rainfall that is less than 9.01 inches. So I could, because it said percentage, I'm looking at the relative to help me. And I could, because it's less than 9.01, I could add up all of the ones that are below 9.01. So I could add up 0.12, 0.14, and 0.30 to get 0.56. Or I could just look at the cumulative, because I'm looking at everything below 9.01, which is essentially the cumulative. So I could just go straight to the cumulative, which is 0.56. when you're adding up many categories, the cumulative is helpful because you just have to go to one. Letter B, find the percentage of rainfall that is between 6.99 and 13.05. So percentage means we're looking in the relative columns again. And I'm going between two groups. So I'm going to just use my individual relative frequency. So between 6.99, I'm starting here, and I'm going to 13.05. So I'm going to have a 6.99 category, so 0.3. And then I'm adding this next category, which is going to be 0.16. And then up through 13.05. So I'm adding the next category. So all three of these categories. So 0.18. And that totals to be 0.64 or 64%. Now, last question says, find the number of towns that have rainfall between 2.95 and 9.01 inches. So the number of towns is just looking at the frequency. So 2.95, so I'm starting here at 2.95, and I'm going up to 9.01, so I'm including each of these three categories because I'm ending at 9.01. So I'm adding 6 plus 7 plus 15. And because it's everything below that, I could just go to my cumulative frequency because that is going to be adding everything below 9.01. So 6 plus 7 plus 15 is 28 towns. So let's move on to our first example here. So our first example on our own says 19 people were asked how many miles to the nearest mile they commute to work each day. I have them listed. They're not in smallest to largest because you can see there's somebody that answered 5 miles here, somebody that answered 2 here, somebody that answered 20. So they're not in order. So we're going to have to kind of look at them to make sure that we have them correct. So we've got, I'm going to just mark a frequency of the number of people that marked 2 miles. So there's 1, 2, or 2. And then 3, there's 1. And then 4. And then 5, there's 1. Another 1. And another 1. And then 7, there's 1. There's another 1. Okay. And then because we don't have any 6s, I didn't put 6 here. We don't have any 8s, 9s. I don't have those on the list. So we skip to 10s. We've got 1, 2, 3. And before I actually mark the numerals, I'm going to just make sure I have the correct number. And then we skip to 12. So there's 1, 2, and then 13. It looks like there's 1. 15, it looks like there's 1, there's 1, 18, and there's 1, oh, 20. There's actually 2 18s. So let's count up here. We have one of, they told us that there are 19, so our total should be 19. So let's just write these out. 1, 1, 3, 2, 3, 2, 1, 1, 2, 1. So let's add these 2, 3, 4, 7, 8, 9. Plus 3 is 12, plus 2 is 14, 15, 16, 17, 18, 19. Okay. So our relative frequency is going to be taking the individual frequency and dividing by 19. So each of these are going to be divided by 19. So let's go ahead and do that. So 1 divided by 19 is 0.05, and we're going to round that to .0526. I did not give you a number of decimal places, so let's round it to 3 decimal places. So we'll round that up to 3. And then this is going to be 0.105. And then another 0.053. And then we have 3, another 2. I'll calculate 3 here. That's going to be 0.1579 when we round it. And then 2 is 0.105, 119, 119. And then 219 is, and then our cumulative relative is adding, starting with the first one, so 0.105, and adding the next one. So to keep the decimals correct, I think we should just add our frequencies. So 2 plus 1 is, that's going to be 3 out of 19, and then we'll add 1, so that's going to be 4 out of 19, and then 7 out of 19, and 9 out of 19. So this one is 0.1579, and then 0.2105. I went to 4 decimal places. I don't need to. 0.368. 0.474. And then we've got 3 more, so 12 out of 19, 14 out of 19, 15 out of 19, 16 out of 19, 7, oh, nope, plus 2, so 18 out of 19, and 19 out of 19. So that one's going to be 1.1 or 100%. So let's just fill these in. 0.737 if you round it. Make sure you're rounding appropriately. And the last one is 0.947. Okay, now we can answer questions. So, we no longer need this question because we filled it out ourselves, so there shouldn't be anything that's wrong. So it says true or false. 3% of the people surveyed commute 3 miles. If the statement is not correct, what should it be? If the table is incorrect, make the corrections. So 3% of the people surveyed commute 3 miles. 3 miles, that is not correct. We actually have 5.3%, 0.053. So that was false. So it's really 5.3% commute 3 miles. What fraction of the people surveyed commute 5 or 7 miles? So that means we have to add them together, 5 or 7. So it's going to be 3 plus 2, so 5 out of 19. It said what fraction? And then D says, what fraction of the people surveyed commute 12 miles or more? So that would be all of these people, 12 or more. So 2, 1, 1, 2, 1. So 2, 3, 4, 5, 6, 7. So that would be 7 out of 19. And then less than 12 miles would be everything below that. So we could do, in that case, we could just say 19 minus the 7, and that leaves us with 12 people left. 12 out of 19 commute less than 12 miles. And then between 5 and 13 miles, not including 5 and 13. So that means we're including 7. So in brackets, we're including 7 miles, 10 miles, and 12 miles. So that would be 2 plus 3 plus 2. So that would be 7 out of 19 people travel between 5 and 13 miles to work. Example 2. You read through this for a minute. The table below contains the total number of fatal motor vehicle traffic crashes in the U.S. for the period of 1994 to 2011. I'm going to look here. Now notice this is one set of data, but there's the year, and then the year starts over here again. So we're going at 1994 all the way over to 2011. And then the second and fourth columns are the total number of crashes for those years. And then we have the total number of crashes here out of all of those years at 653,783. So it says, what is the frequency of deaths measured from 2000 through 2004? The frequency of deaths measured from 2000 to 2004. So that would be adding up 37526 plus 37862 plus 38491 plus 38477 plus 38444. Oh, I'm going to share screen here, and we're going to go to Desmos. And we're going to add these up. 2000, we have 37526 plus 2004. So that comes out to be 190,800. Just double checking my work here. Okay. Number 2 says, what percentage of deaths occurred after 2006? So if we are going to go to after 2006, so that means we're not including 2006, we're including all of these. And a percentage is the total out of this group out of the total. So that's going to be out of 650, 780. So we could go back to here, so 37, 476 plus 1 plus 3296 plus 2977. And then we're going to take that from 62 by 23, and we're going to divide by the 653 and 83. And that should be 0.249, so about 24.9%. Then it says, what is the relative frequency of deaths that occurred in 2000 or before? 2000 or before. So we're going to add up all of the, and we want to know the relative frequency, so that's going to be the percentage again. So we're going to add up all of these. Or before. 36, 250, 37, 37. We'll check the first two numbers, 241, 36, 250. So we have a total of 260,056 out of 653,783. And that is approximately 0.398, so almost 40%. Then it asks for what is the percentage of deaths in 2011. So 2011, there were 29,757, and we're going to divide by the total 653,783. And we get 0.0455, which is approximately 4.6%. Then number 5 says, what is the cumulative relative frequency for 2006? Explain what this number tells you about the data. So we are going to the cumulative relative frequency. So let's just go back to camera here for a minute. So here are my answers for the last. It says, what is the cumulative relative frequency for 2006? So this is the total number, the percentage of crashes that happened through 2006. So we would have to add all of these up through 2006 and then divide by the total. Or we could subtract away the ones that we don't want, which was everything here, which we already figured out in number 2, because we found out everything after 2006. So that means we could take 100% and subtract away the 24.9. And that should give us 75.1%. And there you go. And then that's the example. Our last example, for example, lesson 2.2 is constructing a group frequency distribution. And I have the steps written here for you. So let's go through them. We're going to determine the number of classes. And to do that, we're going to have find the highest and lowest values and find the range, which is the high minus the low. We're going to select the number of classes desired. usually somewhere between 4 to 6, 4 to 7 is good. Find the width by dividing the range by the number of classes and rounding up to a whole number. Select a starting point, usually the lowest value or any convenient number less than the lowest value. Add the width to get the lower limits. Find the upper class limit by going one below, and then find the boundaries. So tally the data, find the numerical frequencies from the tallies, and find the cumulative frequencies. So a lot of times we use grouped frequency distributions when our data is pretty varied and we don't have a lot of repeats. So what we're going to do is, it says here, the number of stories in each of a sample of the world's 30 tallest buildings follows. Construct a group frequency distribution and a cumulative frequency distribution with 7 classes. So I'm telling you what I want 7 classes. So we're kind of skipping this right up here. But then it says find the width by dividing the range by the number of classes and rounding up. So our range is our largest, which is 110, subtracting 54, which is our smallest. So our range is 56. So our range divided by 7 classes is 8. So I'm going to round up to 9 as my width. So I'm going to start my lower boundary here and my upper boundary. I'm going to label them lower and upper as 54. And then I'm going to take my width and add it to get the next lower. So 54 plus 9 is going to be 63. Plus 9 is 72. Plus 9 is 81. Plus 9 is 90. Plus 9 is 99. And plus 9 is 108. And then my uppers are going to be one below. So my upper in the first group is going to be 63 minus 1 is going to be up to 62. So my boundaries are essentially just moving those over here. So I'm just going to write them in here. So this will be up to 71. This will be up to 80. This will be up to 89. This will be up to 98. This will be up to 107. And then we'll add 9 from 107 to 9 is 116. So the upper should also be 9 in their width. Okay. And so then when we go from the lower to the upper, it looks like the difference is 8, but we're always calculating our width from lower to lower to lower, upper to upper to upper. Okay. And then we're going to go ahead and tally. So the number of buildings that are between 54 and 62 stories. So we're going to tally them, and I get 7 in this group. I get 6 in this group, 8, 4, 1, 3, and 1 for a total of 30 buildings. And my cumulative frequency starts with 7. I'm going to add the next one to have 13. And then 13 plus 8 is 21. 21 plus 4 is 25. Plus 1 is 26. Plus 3 is 29. Plus 1 is 30. So those should always match 30 and 30. So please reach out if you have any questions on how to create these frequency distributions or cumulative frequency distributions. And have a blessed day.